Hi and welcome to another very exciting tutorial. Today we're going to build this very simple app here. I'm going to explain its purpose in a second. Let me just quickly show you what it does. So we're getting this nice little welcome message, could also be an onboarding screen the first time our app launches. So we can start now, and we just have several kind of useless items, and we can sort or we can just display the ones that are favorited or have a star. So this is a very basic example that is also going through the web at the moment quite frequently when talking about Swift UI. But what we are interested in, or what we are most interested in, are different so-called property wrappers that we're using in Swift UI, and particularly in the state property wrapper and the environment object property wrapper. But before we actually build this application using Swift UI, let's talk a little bit about the goals of this tutorial. First of all, I'd like to give you an opportunity to understand what property wrappers are. Then we're going to explore two very interesting property wrappers in Swift UI, which is at state and at environment object. And then we will also explore the meaning of the $sign prefix that you might already have seen. So a very interesting aspect of Swift UI is how by changing property states, you can actually trigger UI reloads. So in our example application, the first state that is highlighted here on the left at the moment is fafs only. And once we actually toggle the switch, our state changes, and Swift UI rebuilds the view. This is very efficient because Swift UI uses a diffing algorithm to understand changes and update only corresponding views. And Swift UI stores all of these properties marked with this @state attribute in a special and separated memory where only corresponding views can access and update them. And @state, this is what we call a property wrapper. You can read all about property wrappers in this Swift evolution proposal, but for us and right now, we want to understand what we can actually do with them, and what we can do with property wrappers is making a generic type usable as an attribute. Now that might sound like nothing interesting, but let me give you a quick example to illustrate why this is so cool. So here I have a simple generic type called user default. It does nothing fancy really. We have a value that can either read or save objects to the user default database, and in case you have never used user defaults before, they are an interface to a very simple database where you can store little pieces of information as key value pairs persistently across launches of your application. So we could use, for example, the key username and store a name as its value. And this struct that we have here is marked as a property wrapper. And I'm going to show you what we can do with that right now in Xcode. Now, to get a better understanding of what we are doing, I've just created an empty project that we use to actually have access to the user defaults in the iOS sandbox on the simulator. But let me just quickly show you how we could do this without a property wrapper. So a very common task for using user defaults is, for example, to actually store if the app was launched for the first time so that you could display an onboarding screen or whatever. And this is a case where we have a property that has a little bit more complex logic. So we have first launch, it's a bool. When we want to access it, we get the information from the key or the value from the key first launch, which is also a bool. And if we set first launch, then we write, for example, true to first launch as soon as we start the app for the first time so that the onboarding screen isn't displayed again. So this is a very common use case for user defaults, and we would have to rewrite this whole thing if we actually wanted to create something for our username. The same thing for our username, to also store that and do something with it. So now I actually want to do the same thing using a property wrapper and show you how this works. So first of all, I'm going to define my generic type here, call it user default, which is a generic type. And now I'm also going to mark this as a property wrapper. At the moment, in this version of Xcode or the Xcode beta, we're still using, or Apple is still using, the property delegate term. This has been renamed to property wrapper, but you can use both terms here, or both attributes. We're using property wrapper because this is the one that is going to be used. So now that we have our type here, I'm going to add the logic that is pretty much the same as we just used, with a key, with a default value. When we access our value, we get the information from the key, and the same thing is true for set. We set a new value for the key that we specified. Now, this is now our definition of our type, and now the interesting part is actually using it. We can reuse this for first launch, we can reuse that for our username, and we're going to do that here in application did finish launching with objects. So this is called every time we actually launch our application. And now all I really have to do, let's just quickly define a property here right above application did finish launching with objects. And I can now use my property wrapper user default and directly specify my key that I'm interested in here, which is username, and a default value, let's say user. So now I can use this attribute for my property username, which is going to be a string in that case. And now the cool thing is that we can just work with this string as it were any other string, and we can print, for example, my username is, and then just passing along username here. And now if I want to change my username, all I have to do is use username and set this to Brian, for example. And automatically it is stored in user defaults. Exactly what we wanted. Now, to see if this works, let's quickly run this in the simulator. And if we look at our console here, then you can see we have my username is user. This is the default value that we used here. And if I just run this again, then we should have my username is Brian, because we saved it after the first app launch, and then we have to relaunch it to actually get to this print statement again. So as you can see, we have defined a generic type here. We have marked it with the property wrapper attribute, and now we can just use that using at user default, and then we have a very common string that we can work with, but that has a lot more power. And I believe that now that you've seen how property wrappers look from the inside, it is easier to understand why we're using them. And we can now have a look at the property wrappers that are used in Swift UI. We have binding, we have environment, environment object, object binding, and state. And we're going to focus on these two, environment object and state, right now in practice. So in Xcode, I've just created a new single view application using Swift UI, and I've changed nothing else here. So you can just go ahead and follow along. And the first thing that I like to do is to prepare some data. So I'm going to select the app.delegate.swift file, press Command N on the keyboard, and create a new file. And I'm going to call that just data. And we're going to import Swift UI right away. And I'm just going to create a struct here, calling this random item. And I'm going to adopt the identifiable protocol so that we can use a list in Swift UI. That requires us to have an ID, which I'm going to use a UUID for. We're also going to have a name, which is going to be string. And let's maybe say favorite, because we want to be able to star an item. Well, you actually do not have to create an initializer for a struct, but I'm going to do it using a name string and a favorite bool, because I do not want to define a UUID every time I create an item. So I'm going to use self-ID and directly initialize that with a UUID using name from the parameter and also favorite from the parameter. And having now such a random item struct, I can just paste my data that I'd like to use. I've just created an array here, called that item data, and just placed 7 items in there called item 1 through 7, and some of them are set to true, so that we can display a star. Some of them are set to false, and that's just it. Now, let's go into our content view, and we're going to start with our rows for the list. So I've just hit resume here on my canvas on the right, and as soon as I have my preview, let's zoom out here a little bit, we're going to get started. We're going to start with a text. This was something like item 1, and then what we also want is our fav icon, so our star. I'm going to use an emoji for that, just copy that real quickly, and to actually display them side by side, what we should do is place our hello world, or our item 1 here, in a horizontal stack so that we can put items next to each other. And then I'm going to add a new text here just for my star icon, which is, as I said, an emoji. And I don't want my two texts side by side, so I'm going to use a spacer between them, which fills the gap between both elements and then uses the whole screen. Now everything is pinned a little bit too much to the edges, so I'm using a padding on all sides for my whole horizontal stack. This is actually going to be my row, so I'm just going to copy that code real quickly, and right below my content view, I'm going to create a new struct. I'm going to call that item row, which is, or adopts the view protocol, and here we have our body, some view, and here I'm going to paste my stack. Now, with our row item finished, or our item row finished, we can create our content view. So I'm going to remove my horizontal stack here, replace it with a list, and we're going through our, what did we call it? We called it item data. So we're going through the item data, and we're going to have an item for each row so that we can now use our item row inside of our list. And let's quickly resume that. And we should have 7, 1, 2, 3, 4, 5, 6, 7 items right here, but they're not dynamically populated yet. So what we should do is introduce a new property to our item row struct. I'm going to call that item. It's of type random item, and then instead of the text, the static text item 1, I'm going to use the item and its name. And for the star icon, I'm going to use an if statement to check if the item is a favorite, then we are going to display the star icon. And now all we need to do is actually pass along the item as a parameter in our call here in our content view. So I'm just passing along the item from the list, and now we have a dynamically populated list here on the right with only the ones where our favorite property is set to true with a star. Now we also want this toggle button, the switch button, right on top of our list here. So in order to do that and to add another list item that has nothing to do with the elements that we have here, I am going to rename my list here with for each, which works exactly the same way actually, and place a list around that. So let me just quickly add my curly braces here and add indentation. And now we actually want to add our switch, or our toggle button, but we need to store its value somewhere. So we're going to add another property to our content view struct. And I'm going to call that favs only and set this to false as an initial value. But this is actually our first encounter now with a property wrapper, because we're going to use the attribute at state right here. And as you remember, when we change a state, our user interface gets redrawn or rebuilt. And we can change that state now by creating a binding between our toggle and the fafs only property. So let's quickly do that. And in our list, in our content view, I can now create just another toggle. As you can see, it requests a binding of type bool, and we can just pass it along. But as you can see, it is not just a bool, it is a binding of type bool. So what we have to do here is now use the $ prefix and pass along the fafs only property. Now, let's quickly finish this toggle button by adding a closure here to actually add a text with stars only. Just quickly copy my star here, copy that, paste that right here, build that, resume, so that we can see if we have our toggle button, and indeed here it is. Maybe just one last cosmetic change here, adding a leading padding here to bring all of that in line with our items. But now, what does this $ prefix actually do? Well, our toggle doesn't really want the actual bool, but the binding property provided by the state property delegate struct, which will be able to trigger a view reload when it changes. So let's have a quick look at the definition of our state property wrapper. Still property delegate here, but property wrapper in the future. And as you can see here, this is the binding property that we are interested in, and this returns a binding referencing the state value, and in turn, this is what later triggers our UI update. So if we have a look at fafs only, using a dot to actually access all of our properties, you can see that we cannot really access the binding. But using the $ prefix and fafs only, we can now access the binding. So even though fafs only is a bool, I might still want to access the properties and methods from the more complex generic type in state, and for that we are using the $. I hope this helps you understand why we're using the fafs only with the $ prefix and how all of that comes together. But with our binding between our toggle and the fafs only bool now in place, we can change which items we're seeing and which we don't, depending on toggling this button on and off. But therefore, we're going to need a little if statement in our for each block here. So I'm going to say if not self.fafs only or item favorite, then we actually want to display our item row. This condition might look a little odd, but pause the video here and think about it for a second by looking through each of the lines one by one and see which ones should be actually active or which ones should be displayed when we toggle the button and we only want the faf'd ones, and when we actually want to see all of them. Just hit pause, think about it for a second, and then it's going to be pretty clear. And so far, we have only used one state property to actually display only the faf'd items in our list. Now, we actually need to build a very similar construct to display an alert view in SwiftUI. Since we're working in a declarative way here, we need to define kind of all the things that are possible. And I'm going to create a new state property here that is going to be called display alert. I'm going to set this to true for now so that we're also able to see something. And I actually want our list to present this alert. So I'm going to use the presentation modifier right here and use, again, our binding to display alert right here. And then we're going to add a closure here to create an alert with a title, which is going to be a text, let's say welcome. And the message is going to be another text, which is going to be welcome to this great app. And then we're going to have a dismiss button, which is going to be a default button, again with a text that says, let's start. All right, so now we have this alert, and actually should be able to present it already. And here it is, here's our alert. But we're really only want to display that at first launch, just as we discussed earlier with our onboarding screen. Well, that's not a pretty cool onboarding screen, but it'll do. And we actually want to use user defaults to actually work with that. But how can we do that? Well, first of all, let's reuse the code that we have already written earlier. Create a new Swift file. Let's call it user default. And I'm going to just add our property wrapper that we have created earlier in this video. And now with our user default property wrapper, let's create a new file, new class, call it data store. We could use that for different things, but I'd like to use it for actually working with the user defaults. And we're going to use Swift UI here, and we're also going to use the new Combine framework, which is pretty cool. We're going to explore that in a second. Let's define a final class data store right here, and this is going to be a bindable object. When we create such a bindable object, it is necessary to actually create a didChange property. In our case, this is going to be a pass-through subject. And using a pass-through subject, we can define what kind of an output we'd like to have and what kind of a failure. And I want data store as an output, and I do not want this to ever fail. So I'm defining this with never. And now we can actually create a new property here, which is first launch, a bool. And the cool thing here is now that we can just use our user default with a key. Let's call it first launch and the default value true as an attribute for our first launch property here, so that we can directly save and persist data when we need it. Now, what we also need to do is to actually tell our didChange property when something really changes. So when we did set a new value for first launch, we're going to use didChange. We send ourselves so that we know that all our subscribers know that there is an actual update. So didChange is, in terms of the new Combine framework, a publisher, and it's going to notify all its subscribers when something changes. And that's why in didSet of our first launch property, we're also sending the current state of our data store. We could include more useful information here. For example, if we downloaded information from the web and something changes because of a search or whatever, but for demonstration purposes, this is just enough. So now how do we make this information available to our whole view hierarchy? In our case, it's pretty simple because we just have this one view. But what if you had many views? Now, this is where environment object comes into play. At the moment, we've used these two state properties, and state properties are accessible only to a particular view, in that case, to the view we're seeing right here. But environment object is going to be available to all our views in the view hierarchy as soon as we define that. So let's have a quick look at the scene delegate file. And as you can see here, there is a UI hosting controller defined where we're actually calling our content view. And now, to make our data store available to the whole view hierarchy, all we have to do is use the environment object and pass along our data store. And now we can use that in our content view and in all the other views that we actually need. So let's define a new environment object variable data store of type data store right here. And what we can do now is we can create a new function right below our body. Let's call this maybe show alert. And now what we can do is use the data store and check if we actually have our first launch. And if this is true, then we actually want to display our alert and set this to true. And after the first launch. We actually don't want the next launch to be the first launch again, so we're using our data store, use the first launch property, and set this to false. And thanks to our user default attribute, we actually store that in the user defaults, and it is persisted for the next app launch. And now we still have to connect our show alert function to the rest of our UI. And we can simply do this by checking every time our list actually appears. So we're adding the modifier on appear, and here we simply want to perform the function show alert. That's all. Now, with that in place, let me set display alert to false here. Let's maybe we'll just run this in the simulator. It's going to be a little easier than here in the canvas. And here we are, we have our first app launch. We get our welcome message, our great onboarding screen. We can start, we can trigger our toggle here, and everything is working just fine. Now let's quickly restart this, and we should be able to see our welcome message again. And indeed, we just have our list, no welcome message. And with that, you have actually seen how environment object works for the whole view hierarchy. You have seen how state actually works for this single view. And now just to quickly wrap this up, if you want to see all of that possible or make your data also available in your preview in the canvas, all you have to do here is also pass along your environment object, in our case the data store, and then this also works in the canvas. Now, I hope this clears up a little bit about how state and environment objects work, what property wrappers are, and how you can use all of that together to build great Swift UI apps. I thank you so much for watching. Make sure to subscribe to this channel if you don't want to miss any new videos. If you like this video, give it a thumbs up, and I'll see you in the next one. Bye.